Next, let me go for the derivation of determining the centroid of the rectangular sections. Okay, so yes, this is a rectangle now. Oh, nice. This determining the centroid of the rectangular section. So see, this is the rectangular section where A is the x-axis and B is the y-axis. Okay, x-axis and y-axis are shown here. X is x distance, it is been shown as a and y distance, it has been shown as a B. Okay, so you have to determine the centroid of this section. So now what I will do is, you can see here, whatever the section is there, that section is been divided one small, I have taken one small area. That small area is dx. Okay, so in that dx I have dotted one small dot. In that is a distance from dot to the origin, that is an x distance, and y distance I am shown in the left extreme corner. So distance from an origin to the that point, that is a y distance. Okay, one is x distance and one other is a y distance, as I shown here. Dx is the smallest area. For that smallest area you will get a centroid CG, which I shown it as a dot. Okay, now you have to determine the CG of this rectangular section. So for the finding, for you take the first, what you have to do is, you have to take the smallest area. Okay, so the smallest area, that is dx. Okay, so for what is this, the area of the next, for the area of that elemental area is nothing but dx into b. So area of that area is dx into b. Okay, this, whatever the strip I am taking, the area of that strip, a small strip, whichever I hashed, so that hashed portion is dx into b. Okay, so a small elemental area will be dA. Okay, so now I want to find out the area of that small strip. Okay, so you can see that I have shown in the left corner, you see that there is an integration equation. So it varies from bottom 0 level to the top level area A. Okay, so consider it varies, area varies from 0 to area of that strip is A. Okay, the area of that small strip is area into breadth into depth. Breadth is dx, depth is b. Okay, so it is total area will be b into d. Okay, so b into d, so that's what I have written here, b into dx. So b is a constant that you have to remove the outside. So next you have to integrate only the dx. So if you integrate the dx, you will get the integration of dx is x. Or the upper limit and lower limit you have to put it as 0 and a, because it is, we are integrating from 0 to a, where our lower limit is 0, upper limit is a. Okay, so if you make it that upper limit and lower limit as 0 to a, so x, if you place in the place of x, if you place a, and x in the place of x minus, in the place of x you have to put 0, means a minus 0, you will get it, finally you will get ab. Okay, if you integrate, sorry, if you put the limiting value of a and 0 for x, you will get only a. So finally the area of that small strip will be small a into b. Okay, so if you take for the sorry, for the total area of that rectangle section will be a into b. Okay, that's what the differential of the elemental area. So next, we want to find out the centroid of this equation. Okay, centroidal of this equation, what is that? According to centroidal equation, it is the summation of small elemental area into the difference, or distance from the centroid to the origin. So x into dA. So you are what, that is the summation. In the definition it is the summation. Summation and integration both are equal. So in the place of summation I am using integration. Integration of distance is x, different, and x is the distance from the CG, and dA is the small elemental area. Okay, so divided by total area. So that's what the that's what the definition according to the according to centroidal equation. So which I shown it in the previous, uh, which I showed it in the previous. Okay. That's what you have to take it. So dA, what is that? Integration is the whatever it is, then a distance from the CG of that elemental section to the origin. So distance is x, elemental area is dA. So dA into x divided by summation of area, which I have determined, which we have determined earlier. Okay. So x into dA is the, we have already we have determined in the top. You see that dA is equal to b into dx. Can you see here at the top, where we have determined the area of the differential element is dA into b into dx we have taken now. So I am substituting the value of dA to the b dx. Okay. So after that, the denominator in the area, in the a is substituted by a into b, which is in the rectangular box at the previous one, which we have been determined. So limiting value will be from 0 to a, because we from a 0 value to the, from 0 origin to the maximum is the area value of, after taking all the strips, the total area will be area. Okay. So that is the maximum value. So it will be from 0 to a. Okay. So next, we denominator ab is a constant, you remove outside. In the numerator, x and dx is the variable, you have to integrate. B is a constant, you remove the outside. So x divided by ab will be, sorry, b divided by ab will be at the outside, and if you integrate x with respect to dx, you will get x square divided by 2. Okay. So with the limiting value of 0 divided by a. So finally will be b into bb will, both the numerator and denominator b is there, so both you will get cancel, and finally you will get with respect to x square divided by 2, with the integration value, with the integration limiting of from 0 to a. If you do the integration, you will get the a square divided by 2 divided by a. So finally a square and denominator a is there. If you cancel that, you will get finally x bar is equal to a divided by 2. So x bar is the nothing but the distance, x distance from an origin to the CG, x distance will be a divided by 2. Similarly, we will do for the y bar also. Y bar also same like as it is like a previous one. Here you have taken x into dA divided by a. This is x distance, but for this you have to take y distance. You can see here y bar is equal to integration of y into dA divided by a. This is common. First numerator, what is that? It is a distance into elemental area, small elemental area you have to take it. This numerator is integration of distance into elemental area dA divided by total area. So your total area is a. So same you in the previous, dA is equal to here b, y is here b divided by 2. What is that b divided by 2 is, you can see here totally distance is b. So at centroid it will be existed, the dotted point will be at the center, so it will be b divided by 2. So y bar will be y distance, whatever I am shown here, y bar distance will be b divided by 2. So that's why y here is y, integration of y, in the place of y it is b by 2. Next dA, you can see here, dA whatever I used, dA here is b into dx. Same I am using here also, dA is equal to b into dx. Area is equal to a into b. The previous also area I have used area as a into b. Same previously, x bar and y bar will remain same. So x bar is x bar and y bar is the distance, that's all. Okay. So here it is in place of b dA, it is b into dx. If it b divided by 2 and ab both are constant, you remove the outside, and if you integrate next it remains in the another bracket, it is b into dx. So b is also constant, you remove outside. So totally b square divided by 2, it will comes to the out of the integration, and only you will rest with the only the dx. If you integrate, you will get x with the lower limit of 0 and upper limit as a. So in denominator it is ab, so divided by ab. So finally if you substitute the upper limit of a and 0 in the place of x, you will get a, that's all. Okay. So b square divided by 2 divided by ab. So bb, you both, you will get you make it cancel, and in the place of x you will write it as a. Finally after doing all the cancelling, you will get y bar as b by 2. So you can compare this with the previous one. So x bar is a by 2. So x distance will be whatever a distance will be there, that is the length divided by 2. So length divided by 2 will be x bar, and for y bar b divided by 2. What is a by 2 and a and b? You see here, a is length, b is breadth. So a divided by 2 is the x-axis and b divided by 2 is a y-axis. So that's what, anything which is passes through x-axis and y-axis exactly at the center, that is nothing but the length divided by 2 and breadth divided by 2, that is will be x bar and y bar. So this is about the centroid of an rectangular section. So this you have to be you have to determine, and it's most important for the examination point. So try to do this. This is the first one. If you do this one, next you can do the rest of the things.